clear one. When you have the word public in front of the tag box.
Yeah. This is what we call the inheritance specifier. I will come into it. It has a meaning and it has an implication on what variables you also can access and what you cannot, right? So it adds another knob of flexibility to what you can inherit and what you cannot. So that's C++, good. So let's define our point class. Something good about online GDB is you can add files as well. So we will apply the concept of separation, similar to what we do in the lab, separate the definitions from the implementation. So we'll have a point.h where I define my point class. This a little bit bigger here. Say class point. And then here we have protected. And then I have int x and y. And then I have public. And this is, we want to have the set. So this is void set int a int b. One thing we can do in member functions of a class is what we call inline definition of a function. And maybe this is the first time we discuss this. So simply, if the function can be implemented if the function can be implemented in a single line, I don't need really to define its prototype and then add it later in the implementation. So what we can do is define it in line, do something like x equal a, and then y equal b. So this is called inline function definition. Yes. No, lambda is completely different thing in C++. So we don't cover lambda of C++ in that course because it's a bit of an advanced concept. But this is referred to as an inline function. It just has, well, lambda is more like a functionality thing. But here, the whole thing is just, it's completely normal function. It's only the matter of how easy to write it, right? That's the thing. So that's a possible syntax. Another one is the normal one we have, which is only have all the definitions here in your header file, and then add another implementation file. And in that case, you need to include your point.h. And then now you implement your set function. So the way it's a void, so it doesn't return anything. The way you can have a member function is you write the class name, and then it was set function, and then it takes a and b. And here, what do we do? X is equal a, and y is equal b. Right? So here we had a header file that defines my member variables as well as my functions. And then here, that's the actual implementation of the functions. Good. So now we have the point class. It's a very easy class. We will maybe add into it later on. But let's say now we have this point class. I want to inherit this point class for a child, like either point 3D or circle. So what can I do? Simply just have another class called circle. And then again, I'll separate it into a header and an implementation. And then I use class circle. In that case, I want to inherit. So I want to say public and then point. And again, don't worry about this public for now. We'll discuss it in a second. But the way to read this is circle is a child of the class point. Good. Oh, I guess I forgot something here. So what do you want to add inside the circle? So we said we inherit everything, including x and y in the set method. But for circle, we also need radius, right? So I'm going to add int radius or r, whatever you want to call it, right? And then, in fact, I might add another I might add, and let me think how we do it. We can do it using different ways. So you can add another method called set radius, and then this is just returning void, and then it takes an int radius as an input, and then maybe this one I implement as an inline to show you how it works, and then r is equal radius. And that's it, right? So this method wasn't there in my point class because there was no radius there, but I'm just adding it, okay? in the circle class. Do I really need a circle.cpp? Well, for now we don't add anything else, so let's just keep this as is. And then I might just add a point3d class as well. Oh, something I have done here that we need to pay attention to. Because you are using the point class as a parent, within this file, point is not known, right? So what do we need to do is to include point.h, right? And then here in point3d, you also include point.h, and then you define your class point3d. And this is a child of the class point. And then, well, did I also forget this here? And then what do we want to add for the point3d? We said we inherit x and y by default, right? But we need the third coordinates, right? So in that case, I'll have a protected member called z, and this is nz. For this one, I might also need to set, right? So in that case, I will do it a little bit different by doing the following. So I have a public method that I'm going to call set only, not set z. And then in that case, set will be taking int x, well, int a, int b, int c. And then, well, I might also implement inline by saying x is equal a, y is equal b. Oh, this should be semicolon. And z is equal c. So, well, this now will teach us one special lesson about inheritance that I will come into. But overall, what did I do here? I only defined a child class that is inheriting point. I added a variable called z. I by default inherited x and y, right? And then I added a method called set. Why this thing I'm saying is special? Because the parent already had a method called set, right? So if we go to circle, the method, the parent didn't have a method called set radius. So I'm adding a new method. But what is a little bit special here is the parent already had a method called set, but I'm kind of redefining it, right? This is called overriding in inheritance, right? What does it mean is that a child defines a method, but in fact, in a sense, this is also overloading because you have different number of input parameters. Well, this is quite interesting. So let's also do this. Void set int a, int b, and in that case, I will set x to a, y to b, and then z I will just set to 0 because I didn't get any value from the user for, just to show the difference between both. So the main difference between line, and you have to pay attention here because that's a very important trick in inheritance. The main difference between line 7 and 8 here is in line 7, that's something, in fact, I could do even without inheritance. I can even do in C, not C++, which is having a function with different number of input parameters, right? This is called overloading in general. And the compiler will know which function to call from the number of input parameters I'm using, right? This is called function overloading, and this is done statically. This is usually referred to as static binding. Why is that static? When people in programming say statically, it means they are at compile time, not at runtime. While the compiler is compiling your code, it sees how many input parameters you pass to a function through a call, and from this number of input parameters, it knows what version of the function to call. Good? This is why it's static. And this is line 7, called function overloading, right? Again, it's not related to OOP. It can be even applied to C or any other programming language outside of classes. 8 is a little bit different here, because 8, you are defining a function called set with 2 input parameters and returning void, which is exactly the same as the one in the point class, right? If you go back here, line 5 is exactly the same as line 8 here, right? Correct? It's exactly the same function in the parent and in the child. Good. So the compiler has no way to know statically which function to call, because it's the same number of input parameters, same return type, same name, same everything. This is called dynamic binding, because it's only determine what function to call during runtime. How the compiler will know during runtime? Well, it will depend on what object you are instantiating this function from. So the child is able to override, this is called function overriding. So the child is able to override a function from the parent by re-implementing it, right? By having exactly the same signature, same prototype, but implemented differently. How did we implement it differently here? I just added like another line, which is z is equals u, but we can do whatever we want, right? Does this make sense? So let's see how really, yeah, please. Yeah. Are you referring to line 7 or line 8? Line 8, the function is just exactly the same, right? When I say the function, I mean the signature, right? But the implementation is different. I guess your question is which one is going to be called, right? Well, this will depend on what object you instantiate in your main, as we will see right now. This is why it's not really determined statically. We cannot say which one can be called. Only when you run your code, depending on what object type you have, you determine what function to call. And this is why people call it dynamic binding, because the hardware or the compiler or the language only knows during runtime what function, what correct function to call, right? So let's see, when we use it, we will see really how it really works. So here in the main, let's have some fun. So we will include point, well, let's say circle dot h. Good. So I define a class of type point, and let's call it point 1 or well, parent point, because that's really the parent. And here, the way to access the member variable, let's try one of the things we have said we are going to try. So if I want to say parent point dot x equal 3, let's see what we will get from the compiler. Or redefinition. Is that because I included? Okay, so that's because it exists in both places. So let's have this. So do you see the error that we're getting here? So there is an error on line 17. It says, I don't know if you're able to read, but we make a little bit bigger. Oh, it's also in red, which is very tough. But it says X is protected within this context, right? Which means I cannot really access the member X within the point, right? Is that expected? Yes, because X is protected member. If I go and change this to be public instead, and rerun, well, it works fine, right? This tells us that if you have a public member variable or public member data, it's accessible from anywhere. But if you have it protected, it's not accessible except from your own members as well as your choice. Good? So we want it to be protected. But if I want to modify X, what can I do? well, you have the means, so you have the setters, right? So you can say parent point dot set, and in that case, you are passing some values to x and y. So let's say I'm passing 10 and 20. Okay, so in that case, I'm using the right mean that the programmer has given me to be able to set the variables. So it works completely fine, right? So if we wanted to double check this, well, in fact, we might need a getter as well. So I might go here and say void get x, and then in that case, I would say return x. And then the same thing for y. Because otherwise I don't have a mean to read x and y, right? That's the problem. So it's a return y. So in that case, I might just try to say printf. Well, for printf, we might need, or well, let's just use cout for now. Cout x equal, and then what do you want to print? Parent point and dot get x, because we want x, right? And then here I have another space, and then y equal, this is parent point dot get y, and here I just have a new line. Good. So in that case, I'm well, let me just cite before, which is before printing, before setting it, sorry, and then here after we have set it, we get it after. We just run. So before I got x equals 0 and y equals 0, and then after I got 10 and 20, right? So this is telling me that in fact my setting is working, and also my getters, right? Is there any question? So far, all this example, we didn't do anything with inheritance, right? I only within the main use the point class. This should be an application of what you have covered in the past week. Is there any question here? Okay, given that we are spending more time before we delve into inheritance, it might be also good to revisit some of the constructor concepts, because they will come into us also with inheritance. So far, my only mean to set x and y was to use the set function, right? There is a special function of a class called constructor. What does a constructor do? It's simply, you can think of it as any normal function except with one special feature, which is this function get called by default when you instantiate the object. So when you create, for example, in this line, when we create the parent point, it calls the constructor of this class, right? So it allows you to initialize things. By default, if you didn't have any constructor, there is what we call the default constructor. So every single class has a constructor by default, even if you didn't add it. If you didn't explicitly add this default constructor, which takes no input parameters, basically the language adds it for you, for C++. So this is the default constructor. And then there are other two cases that people are using constructors for, which you also see in your lab, by the way. The second one is initialization constructor, where you have a constructor, you pass into it input variables to set certain values, right? The second one is called copy constructor. Instead of passing variables, you pass into it another object where you copy all the values from this object to your own object. In the lab, in the matrix class, you are required to write the three constructors, right? The empty constructor, which is the one that takes no input parameter, the initialization one that takes row and like basically an integer for the row and the integer for the column, right? And then the third constructor is the one that takes the number of rows, number of columns, and another matrix called table, right? And then you copy all the values from table into your matrix. Good. So, and as I said, if you didn't add any constructor, by default, there is the empty constructor. So now let's add some of the constructors here. So one of them is, again, the default constructor. I'm going to overwrite. Constructor must have the same name as the class. Yeah, it initializes. Correct. Yeah, it initializes, you remember, variables to 0 by default, right? Yeah. So I have my here, if you just do this, this is just your default constructor, right? You can add whatever you want in your default constructor as well. For example, I might just say, by default, I'm going to set x to 1 and y to 1, right? It's just up to me, right? You do whatever you want to do. So in that case, let's see what happens if we run our code that way. In that case, you observe that before you do the set, x now became 1 and y became 1, right? Because you overwrote the default constructor. But then usually it's handy to add initializations within the constructor. In that case, you have another constructor that takes just simply the setting stuff. So it takes a and b as input parameters and just sets x equal a and y equal b. So this is the setting constructor or the initialization constructor. The third one is a copy constructor. So it takes as an input another point class. So let's say point, and then, well, we can call it source. And in that case, you can say x equal source dot x and y equals source dot y. Just simply copy the values from there. And I will come into line 7 for now, but let's really see how to use different ones. So here we have seen really how to use this one, which is parent point. It gives you 1 and 1. But if you really say something like this, point parent point equal point, and then you give the values, what values you want to give this to. Let's say 100 and 200. So in that case, you are passing, just give me 1 second, okay? So you are just passing the input parameters while you are creating the object, instead of having it as a second step for the set. So if you run there, invalid constructor, you probably meant point, const point, okay. So let's wait for a second for this one. And let's just do that. Is there another problem here? X equal, oh yeah, I'm forgetting a semicolon here. So in that case, you get x equal 100 and y equal 200. Why did this happen? Because in the main, I just simply pass two values while I'm creating the object, right? So this is the initialization or setting constructor, right? Please go ahead.
Yeah, so when you're calling that main, are you static binding, like are you using static bindings to differentiate?
Yeah, that's an excellent point. Thank you. So your friend question here is that I have different constructors. So how do I know really which one to call? And yes, this is just the rule. Constructors are just normal functions. In normal functions, if you have the same function name but different number of input parameters, this is called overloading, static binding, and hence the compiler will know by default. If I didn't pass anything, so if I just had this as an empty, it will call the one with empty input parameters. If I just do this, it will pass the correct one. That's correct. Yeah. Yep. Yeah, that's a good point. I also wanted to write this constructor exactly for that reason, because here we are within the scope of the point itself, right? So we said even if X and Y are protected or private, I can still refer into them within the scope of the class, right? So this is why this might still be allowed. I need to still figure out what is the problem with this, so we can think about it. Please go ahead. It's protected, so it shouldn't be an issue, but let me see what was exactly the error. So I guess it said point is not really defined. Let's really have a pointer instead to and see if that makes sense. And let's separate the concerns. So let's also use get X instead to just avoid the point that you were saying and see if that makes sense. Okay, I guess I'm just doing something texting here. Yeah, I'm just forgetting semicolon. Okay, so that works. So let's then see if we can use just X. Oh, but this should be small x. Okay, that also works for the reason that I was just mentioning right now. This should be this y and this one. Yeah, okay. I guess the whole point was about passing really an object, not a pointer, within a class, but pointer should be fine. So this is basically the copy constructor. This is the third constructor you need to do in your lab as well, right? Which is the table one that is taking a double pointer matrix, right? And copy the values from there. So this is similar to what we have done here. It's just simply having another pointer to an object called source and copy the values from X and Y. Let me first see how to use it. So I will come somewhere here, define another point class. I will call it, copy point. And then I will initialize it to some value that is 1,000 and 2,000. And then I will just call this after 1. And then here I will call, I need to define another one because otherwise the constructor will not really work. So I will call point, parent point, but this shouldn't be parent point. And so parent point 2. And in that case, I need to pass into it a pointer to, so first of all, let's define the pointer. And this is pointer point. In that case, it will take the value point. So what I'm doing right now. So first of all, line 21 is just defining another object of a class, right? This is the class name, point. This is the object name, copy point. It can be anything. And then here, I'm just calling the specific initialization constructor, passing 1,000 and 2,000, right? It's a very simple line. Then now, this is also interesting to see. I'm defining a pointer to the object. It has nothing new at all. All what we covered in pointers still applies. You can think of classes as just normal types, right? So if I want to define a pointer to that class, I just use the type name, which is the class name in my case, adding the asterisk, identifying that this is a pointer, give the pointer name, and then give the address to the object I want to pass to. This is why the AND operator, right? Remember, this line 22 is exactly the same as int pointer equal and x, for example, right? And then once I have a pointer to that object, I'm defining a third object. I'm calling it parent point 2. And in that case, I want to initialize it using the third constructor. So the third constructor simply takes the pointer, right? So I'm just doing this. And I want to print, I just want to print it before and after as well. So here, but there is no before and after because it's just simply within the constructor. So in that case, parent point 2, parent point 2. So the question is, what are we expecting out of line 24? What output do you expect from parent point 2, x and y? Yeah. Yeah, exactly, 1,000 and 2,000, right? Because what I do in line 23 is just take the copy of that other object and take the values from there and copy them. So let's see if this holds. So here I'm getting x and y is 1,000, 2,000. This is what we expect, right? So one question to you. If I have, and this maybe we conclude the lecture with this, we didn't even start inheritance, but it was a good revisit for the class concepts and constructors. So if I already managed to set the values of the constructor the values of the class from the constructor, do I still need the set function? Because in a sense, this constructor here is doing exactly the same function of the set, right? Can I get rid of the set? Yeah. Yeah. Yeah, exactly. So put in mind that you cannot really call the constructor yourself, right? I cannot come here and say something like, well, parent point to dot point and then pass something, right? Pass another, well, again, pointer point if I want, or say 1,000 and 2,000. I cannot really, line 24 is a syntax error. Why? Because you cannot call the constructor from the code. The constructor is called by default when you create the object, right? So you cannot call it. So if you want to set the values of the object after you create it, you don't have a way to do this through the constructor. This is the reason why you need the set. This makes sense? Good. So let's stop here and then we start the inheritance in reality. We will build on top of this example on Tuesday. Good. Thanks, everyone.